All right, so today you're going to be taking test number 9 over TEKS 6.8 C and D, which is calculating speed and graphing motion. Take a good look here at what we got going on. So a couple things here to start out with. You're given the speed formula, which is distance divided by time. Using the distance time graph provided, calculate the average speed of the object in meters per second. So find a data point on there that is easiest for you to calculate your time and your distance. Do not forget the distance formula is on the question. Using the information provided in the chart and the formula for speed, what is the difference in speed between car A and car B in feet per second? Make sure you can find car A, and then you'll want to find car B. Calculate the difference in speed. Is the difference in speed A, 6 feet per second? B, 3.2 feet per second? C, 2.8 feet per second, or D, 2.0 feet per second? Suppose you go for a jog and you travel 4 miles in 30 minutes. What is your average speed doing your jog in miles per hour? Again, don't forget the speed formula. It's distance divided by time. So go ahead and calculate your answer based on your distance and your time provided. Looking closely at the graph, describe the change in speed of the object. X-axis we have time, Y-axis we have distance. You have your line. Is it A, the object speeds up? B, the object slows down? C, the object doesn't change speed? Or D, the object maintains a constant speed? Look closely at the 4 trials of data from the rolling ball. What is the speed of the ball in trial 3 in meters per second? So there's 4 trials here. The question is asking about trial 3. So go ahead and calculate your speed. Remember, the speed is distance divided by time. Using the runner's race graph, which statement below best describes the motion of the runners? So we have runner 1, which is our solid line, runner 2, which is our dotted line. Is it A, both runners travel the same distance in 120 minutes? B, runner 1 has a speed of 20 kilometers per hour? C, runner 2 stops between 40 and 60 minutes? D, both runners cover 20 kilometers during the race. Which one of those statements best describes that graph? For this graph, you'll know there's a green line and there's a red line. Looking at the distance time graph, calculate the speed of the green runner in kilometers per hour. Don't worry about that phone ringing. Look carefully at the chart trials for speed. Looking specifically at trial 1, what is the difference in speed between 2 and 3 seconds? So notice there's 4 trials. You have a chart of information here. What is the difference in speed between 2 and 3 seconds? Is it A, 5 meters per second? B, 10 meters per second? C, 15 meters per second? Or D, 2 meters per second? Again, what's the difference in speed specifically for trial 1? Using the distance-time graph, which statement best describes the motion of the object represented by the blue line? This line is blue. Is it A, the line shows that the object slows down and speeds up? B, the speed of the object is approximately 150 kilometers per hour? C, there is acceleration during the 5 hours of data because the line is curved? Or D, the object shows a constant speed because the line is not curved? Looking at the distance-time graph, when does the object return to origin? Is it A, from 1 to 3 seconds? B, from 3 to 5 seconds? C, from 5 to 10 seconds? Or D, from 10 to 12.5 seconds? Looking at the distance-time graph, when does the object return to origin?